Good evening, dear students. Yes. So in the last class, we have started with the chapter chemical reactions and equation, right? So what all things we have discussed in the previous class? We have discussed about the terms, okay? What is chemical reaction? What are reactants? What are products? How the chemical change takes place, right? Then we have seen the different examples of chemical reactions, right? So these were the things which we have discussed in our previous class, right? So then we have discussed how to write the chemical equation, right? From word equation in the form of the from word to the equation form, right? Then we also have seen how to write a balanced chemical reaction, right? What are the steps involved in writing the balanced chemical reaction? How to balance a chemical reaction? So these are the things which we have discussed in our previous class, right? So today we are going to discuss about the types of chemical reaction. Okay. So now we have understood what is a chemical reaction. So today we are going to see what are the types. Okay. What are the types of chemical reaction? So in any chemical reaction, okay, when a chemical reaction is taking place, so atom of one element do not change into atom of another element. Okay. Nor any atoms will disappear from the mixture or appear from elsewhere. Right. So in any chemical reaction, any atom, it won't get what it do not change into another element. Okay. So here, what does a chemical reaction involves? So this chemical reaction, it involves either breaking of a bond between two atoms or making of bond between two atoms. Okay. So like that, the chemical reaction will proceed. So whenever any chemical reaction is occurring, so what will happen? The chemical reaction will occur with either breaking of bond or making of new bond between the atoms. Okay. So let us see what are the types of chemical reaction. So there are five different reactions, okay, which are there in your syllabus. So the first one is the combination reaction. Okay. First one is the combination reaction. Second one is decomposition reaction. Okay. Decomposition reaction. The third one is the displacement reaction. Displacement reaction. Fourth one is double displacement reaction. Okay. Fifth one is oxidation and reduction reactions. Fine. Now, these are the reactions which we are going to study in detail. Now, first one, when we are discussing about combination reaction, onto your left hand side, right? Onto your left hand side, you can see blue color ball and a pink color ball, right? So there is A and B. Okay, so there are two substances A and B. Okay, how they are separated? They are separated by a plus sign in between. So A is a one substance, B is a another substance. So what is happening? It is getting combined. Okay, these two A and B are getting combined. So this will give rise to what? This will rise to combination reaction. Okay, what this is called as combination reaction. Okay, so A and B, they are getting combined. Okay, you're bringing them together. Okay, they are getting combined, so they are called as combination reaction. Okay, second one, what is the decomposition reaction? Okay, decomposition reaction means what? Here you can see A and B are together. A and B, they are joined together. After you do the chemical reaction on that, it is getting splitted. Okay, it is getting separated by A and B. It is getting decomposed. It is breaking. Okay, so here what you can see in the first reaction, there is a making of new bond. A new bond is made between A and B. Okay, so there is a making of new bond. So this give rise to combination reaction. In second one, the old bond, whatever is there, it is broken. Okay, it is broken. So this is called as decomposition, breaking of bond. Okay, so it is called as decomposition reaction. Okay, next one. So this is decomposition. Then what do you mean by displacement? Okay, what do you mean by displacement? Here you can see A and B are together. Okay, A and B are together, and C is another substance. Okay, C is the another substance. So what is happening in the product side? You know that, right? On the right hand side, what all I have written, these are all product. And on the left hand side, it is the reactants, right? How they are separated? They are separated by this arrow mark. So we are discussing the third one. Okay, A and B, they are together, and there is a substance C. So what is happening when they are reacting? A is getting combined with C and B is left alone. Okay, so what is happening? Your B is displaced by the C. Okay, your C is getting displaced by this B. Okay, so it is called as a displacement reaction. You can see there is an exchange. You can say there is an exchange, right? So what is happening here? Your A is getting combined with C. So there is a new bond formed between A and C. A new bond is formed between A and C, and the bond is broken between A and B, and so the B is left separately. Okay, so this is a displacement reaction. Then fourth one. Okay, fourth one is double displacement reaction. Okay, on the reactant side you have two. Okay, you have AB. Okay, AB together and CD together. So both this AB and CD, okay, they are reacting with each other, and what is happening? A is getting combined with D and B is getting combined with C in the product side. Okay, so what is happening here? The old bond which is formed between the A and B is broken, and a new bond is formed between A and D. So what is happening? Double displacement. Okay, both the atoms are getting displaced, right? So it is called as double displacement, right? So this is the fourth type. So again, we are going to discuss in briefly. Okay, so I have just explained you what is a combination reaction, what is a decomposition reaction, what is a displacement reaction, what is double displacement reaction. Oxidation and reduction. Oxidation means addition of oxygen, okay, and reduction is removal, or you can say addition of hydrogen. Okay, addition of hydrogen is called as the reduction. Okay, so addition of oxygen or removal of hydrogen. Here addition of hydrogen or removal of oxygen is called as reduction. So let us study these all chemical reaction. Okay, in briefly, just I have given you in simple. Okay, I have given you explanation in the simple terms. Okay, so let us go for the first reaction, that is a combination reaction. First one is what? Combination reaction. So what is a combination reaction? So these are the reactions in which a product is formed by combining two or more reactants. So just now we have seen, right? A plus B giving you AB. Okay, so this is what is happening here? It is getting combined. A and B, which are separate, okay, they are getting together. Okay, so it is getting combined. So it is called as a combination reaction. So what is happening in the reactant? Okay, two or more reactants, they come together and they give you a combined product. Okay, so this is called as a combination reaction. So this is the definition of a combination reaction. So let us see one example. Okay, let us see a example. So what we have done, we have taken calcium oxide. Okay, calcium oxide, that is CaO. Okay, calcium oxide is CaO. It is called as quicklime. Okay, it is called as what? It is called as a quicklime. So this quicklime, what we have done, we have taken this quicklime in a beaker. Okay, we have taken a beaker. Into that beaker, I have added calcium oxide. Okay, what that is called as quicklime. Okay, it is called as a quicklime. So after some time, okay, what we have done, we have added water to this. I have added water to this. Okay, water is what? H2O. So what is happening? Your calcium oxide is reacting it with what? Water. Water is in which state? Water is in liquid state, right? So I'll write L. Calcium oxide, it is solid state. So I have represented by small s in the bracket. Okay, so we need to mention the physical state. So calcium oxide is taken in the beaker. To that, what I have added? To that, I have added water, okay, which is liquid in state. So what is happening? Now, this will get combined, okay, they will get combined to form you a calcium hydroxide. You get what? Calcium hydroxide. This calcium hydroxide, it is aqueous solution. Why? Because calcium oxide, okay, it is solid. So when you add water, okay, it becomes a aqueous solution. So calcium hydroxide, which is formed, okay, it is a aqueous solution. Plus, there is a liberation of heat. Okay, there is a liberation of heat. So what you can feel if you, so first the beaker, okay, it is not it is normal. Okay, there is no heat, there is no cold, it is normal. The beaker, if you touch the beaker, you can easily hold the beaker. But after you add water, when it forms calcium hydroxide, heat is liberated. Okay, heat is released here. So if you touch this beaker, you can feel heat. Okay, you can feel that the beaker is hot. Okay, so this is a exothermic reaction. This is called as exothermic reaction. So when you add here, when I have added water to calcium oxide, calcium hydroxide is produced with the production of what? Heat. Heat is released. Okay, this calcium hydroxide, it is also called as slaked lime. Okay, it is called as what? It is called as slaked lime. So please remember, what is calcium oxide? Calcium oxide is called as quicklime. Okay, and calcium hydroxide is called as slaked lime. Okay, and the heat which is released, okay, it is showing you that the reaction is a exothermic reaction. So what is this exothermic reaction? So exothermic reactions are the reaction in which heat is released. Okay, so reaction in which heat is released along with the formation of products. Okay, it is called as exothermic chemical reaction. So here, along with our product, so what is our product? Calcium hydroxide. So along with our product calcium hydroxide, you can see that the heat is observed, heat is released. So how you have got to know that heat is released? Because when you touch to the beaker has turned hot. Okay, so this is a combination reaction. Is it clear? Okay, is it clear? So this is a combination reaction. So what we have done, so A and B, okay, they combine to give you a product AB. So here, what is our example we have taken? So calcium oxide is taken. To that, water is added. What is formed? Calcium hydroxide is formed. Okay, so this is a what? So this is a formation of slaked lime. Okay, so this is a first chemical combination reaction. Okay. So where the slaked lime is used, okay, this slaked lime, it is used for whitewashing. Okay, so people, they paint before painting the walls, okay, they put this slaked lime to the walls. Okay, so it is used to paint the what? Your walls. So whitewash is given to the walls. So slaked lime solution, it is used where? It is used for whitewashing. So before applying paint, this should be applied first. Okay, so slaked lime, it is used for whitewashing. So this is the use of slaked lime. Now marble, so marble is also calcium carbonate. So calcium carbonate, the marble which you put for the floor, okay, that also it is made up of what? It consists of calcium carbonate. Okay, so this is about the uses. Okay, this is the uses of your slaked lime and calcium carbonate. Okay, so what are the other examples? So let us see some more examples of combination reaction. The other example is the burning of coal. Okay, burning of coal. So how your coal burns? So carbon, coal is nothing but it is a form of carbon. So carbon, okay, it is in solid state. So it reacts with the oxygen present in the air and it gives you what? Carbon dioxide gas. Okay. So this is your burning of coal. So when coal, when it reacts, so you can see the picture one. Okay. So this is the coal. So coal, when it burns in the presence of oxygen, it releases what? It combines to give you carbon dioxide, which is gaseous. Okay. So this is another example of a combination reaction. Okay. So this is another example of a combination reaction. Next example, formation of water. Okay. How the water is formed? How the water is formed, student? So we know that when two atoms of hydrogen combined with oxygen, it gives you a water molecule, right? So here formation of water. So H2 plus that is dihydrogen gas plus diatomic molecule, that is your dioxygen. Okay, it reacts which is gaseous in state, it gives you water. Okay, so this is the, so your water molecule H2O. Okay, H2O. So two hydrogen atoms and one oxygen atoms forms what? It forms the water molecule. So this is the diagram you can see. So hydrogen molecule combines with water molecule, with the oxygen molecule to give you water. Okay. So this is another example of combination reaction. So I have taken, I hope it is clear what is combination reaction. So I have taken more examples on the combination reactions, right? Okay. So in the first, okay, in your, just now I have told you what is exothermic reaction, right? Now, okay. So here we have understood about the exothermic reaction. So when the reaction is occurring, what is produced? Heat is released, okay, along with the products. So that is called as exothermic reaction. Now we will see few examples of a exothermic reaction. So burning of natural gas, okay, burning of natural gas. So which is the natural gas? Natural gases like your petrol, kerosene, diesel, right? So these are all your natural gases, coal, right? So these are all your natural gases. So natural gases, it consists of, or it is made up of methane. Okay, it is made up of methane gas. So CH4, okay, that is your methane gas. So this methane, how the natural gas, okay, how you burning. So how the burning of natural gas happens? It happens in the presence of oxygen. So oxygen from the air, right? Oxygen which is there in the air, it combines with your methane and it gives what it forms. What will be the product? The product will be carbon dioxide, okay, carbon dioxide plus H2O, plus H2O. Okay, so this is the example of exothermic reaction. So when carbon dioxide gas is produced, so that time heat is released here. Okay, heat is released. So when methane reacts with your dioxygen, okay, so dioxygen, it gives you carbon dioxide plus water. So this is the example of a exothermic reaction. Next one is respiration. So when you do respiration, what involves respiration? Taking in air, right? Taking in oxygen and giving out carbon dioxide. What is respiration? You inhale. What you inhale? You inhale oxygen, and what you exhale carbon dioxide, right? So that involves respiration. So respiration, what is the uh, so the reaction, okay, what is the reaction? So your glucose, that is C6H12O6, okay, which is aqueous glucose, okay, it reacts with oxygen, okay, aqueous oxygen gives you 6 carbon dioxide. So when you exhale, right, so you can do this. So when you inhale oxygen and when you give out carbon dioxide, you can feel the heat, right? If you hold your hand near your nose, okay, when you are exhaling, you can feel the heat. Okay, so heat is released. So this is also one of the exothermic reaction. Okay, so this is also exothermic reaction. So you should be able to tell, okay, what are the examples of exothermic reaction? First one is burning of natural gas. Second one is respiration. The next is decomposition of vegetable. Now, some of the waste, okay, after you cut the onion, the cover of the onion, okay, then whatever the waste it is left in your home, okay, what we can do, we can compost, right? We put them, we keep it together, and this can be used as a compost. So when the vegetables, okay, after some times, when you cover it, okay, when you dig it, when you put a dig, okay, you have to dig some hole in that. When you put this vegetable, so after few days or few months, you can see that the vegetable waste has been converted into a compost. Okay, so here also exothermic reaction is seen. Okay, so the decomposition of vegetable matter into compost. So when the waste, whatever the vegetable is there, when it is converted into compost, so this is also a type of exothermic reaction. I hope it is clear. Yes, is it clear what is combination reaction? Okay, and what are exothermic reaction? Okay, let us go for the next one. Okay, the second one is decomposition reaction. The next one is decomposition reaction. Okay, so in decomposition reaction, as we have seen in the starting, okay, so what is decomposition reaction? Okay, A, B, okay, A, B is breaking down to give you A plus B, right? We have seen this. So A, B, so a single reactant. So this is a single reactant. They are together. Okay, these are together. A, B is together. So, so A, B is together. So a single reactant, it breaks down to give you what? Simpler products. Okay, it breaks down. Okay, to give you simpler products, that is A plus B. So this is example of a decomposition reaction. Okay, so let us see one example now. So what is decomposition reaction? A single reactant breaks down to give you simpler products A plus B. Now your A plus B, okay, it gives you A plus B. Okay, AB is a combined reactant to give you A plus B separately. Okay, so this is a decomposition reaction. So decomposition of uh, carbon, calcium carbonate to calcium oxide and carbon dioxide on heating is used in industries. Okay, so this decomposition of calcium carbonate. So how this decomposition takes place? So how this decomposition takes place? We have to supply some external heat. Okay. So what we have supplied here? We have supplied heat. We have heated the compound. So what we have done, calcium carbonate compound is taken and then we have heated the compound. After we heat this compound, what is happening? It is breaking down. It is breaking down into simpler products like calcium oxide. Okay, like calcium oxide and carbon dioxide gas is released, right? Carbon dioxide is gas is a calcium, carbon dioxide is a gas, right? So this will release, okay? So this will give out. So whenever the gas will release, liberate, you put the arrow upwards, right? So decomposition of calcium carbonate to calcium oxide, which is called as a quicklime, and carbon dioxide, okay? So this is used in industries. So where it is used, this is used in industries. Then calcium oxide, they are having many uses. Calcium oxide can be used in manufacture of cement. Okay, cement is used for construction. So for preparing the cement, for manufacturing of cement, calcium oxide is the main component which is used. Okay. Then when we are using heat for decomposition, okay, such reactions are called as thermal decomposition. So when we are using heat Heat is nothing but it is called as thermal. Okay. So when we are breaking down a, a reactant into simpler products, so we require some external energy. So here what we are using heat. So heat, when we are using heat for breaking down the reactant into simpler products, it is called as thermal decomposition. What it is called as? Thermal decomposition. Okay. So this is the thermal decomposition. So you can see the first picture. This is the limestone. Okay. This is the limestone. So this is the limestone. Okay. For your understanding. And this is quicklime. Okay, this is quicklime. Quicklime will be powdered form. Okay, it will be powdered form. If you hold it in your hand, it will easily become powder. So this is your limestone. This is your limestone and this is your quicklime. Okay, this is your quicklime. So how it looks, right? Okay, another example of decomposition reaction. Okay, so as I have discussed, for decomposition, when we are when we are using a external source. Okay, in the previous, what we have done, we had heated the compound. Okay, for calcium carbonate, what we did, we heated the compound. We had heated the compound. Then what happened? Calcium oxide plus carbon dioxide gas was released, right? Now, in the second example, what we have done, I have taken a porcelain dish. Okay, I have taken a dish. In that, I have taken silver chloride. What I have taken? I have taken silver chloride. Okay, this silver chloride, what I have done, I have kept this in sunlight. Okay, I have kept this silver chloride, the dish of silver chloride in the sunlight. So, as the sunlight rays, okay, sun rays falls on this what on your silver chloride, what is happening? It is getting decomposed. It is decomposed. It is getting decomposed to Ag. It is getting decomposed to silver and chlorine gas is liberated. Okay. So this is another example of decomposition. So here what we have used? We have used sunlight. Okay. We have used sunlight for the decomposition reaction to takes place. So please see the reaction. So AgCl, okay, silver chloride, which I have taken in the dish, it is white in color. Okay, it is white in color. I have taken this in the sunlight. So sun's rays will fall on this porcelain dish, okay, containing the silver chloride, which is white in color. So after some time, this silver chloride, it turns into gray color. That means the silver chloride, which is kept in the sunlight, it is getting decomposed. It has got breakdown into silver. Okay, so this is the reaction to AgCl, which is solid when it is kept in sunlight. Okay. So after some time, when it reacts with the sun's rays, okay, when it falls on the AgCl, it turns gray color. It turns gray color and chlorine gas is liberated. Okay. So this is another decomposition reaction. Is it clear? Is it clear? So we have seen two decomposition reactions. Okay. Easy, right? The reactions are very easy. So combination reaction, then we have seen decomposition reaction. So one more example for decomposition reaction. Okay. So what we have done here, one more example, what we have taken is, I have taken lead nitrate. Okay. Lead nitrate powder in a test tube. So this is a test tube. You can see right on your left hand side. So in this test tube, okay, I've taken white color powder. You can see here lead nitrate is taken, which is white. Okay. What I have done with the pair of tongs. So this is called as the pair of tongs, or it is called as the test tube holder. So by using the test tube holder, I have holded this test tube in the burner. Okay. In the flame. So after you heat it over the flame, what is observed? Okay, what is observed? The brown fumes. Okay, from this test tube, brown color fumes are released. Okay, from this test tube, brown color fumes are released. Okay, this brown color fumes are of what? So let us see the reaction. So what we have taken in the test tube? Lead nitrate. Okay, PbNO3 twice. So what I have done? I have applied heat, right? I have applied heat. So let me put heat. Okay, heat is represented like this. Okay, like this. So this is heat. So what I have done? I have taken lead nitrate. Okay, and what is the external source of decomposition? I have taken heat. Okay, I have applied heat. So after that, what is produced? The lead oxide, okay, solid lead oxide plus 4, that is NO2, okay, that is your nitrogen dioxide, and oxygen gas is released. So the brown fumes which are coming out, this is of what? This is of nitrogen dioxide. Okay, so first the your lead nitrate, okay, what color it was? It was white color. Okay, okay, it was white color. So after heating it, what happens? Brown fumes will go. This brown fumes is of what? It is of nitrogen dioxide. And in your test tube, okay, what left is what will be left will be your lead nitrate. This will be left. Okay, so lead oxide is left. So this lead oxide, okay, this is brown color. So this will be what? It will be brown color, brown powder. So it is converted into brown powder, and brown color fumes will be, it will be out, okay, which is your nitrogen dioxide. So this is another decomposition reaction. I hope it is clear. So here also we have used heat. Okay, so what we have taken? We have taken the lead nitrate powder. Okay, we have heated it. So after heating, what will happen? The brown fumes are given out. Why? Because it represents that nitrogen dioxide gas is liberated. Okay, with the and what is left will be your lead oxide. So this is another decomposition reaction. I hope it is clear. Okay, so we have seen two reactions. That is, one is the combination reaction, and second was the decomposition reaction. So any doubts up to here? Yes? Is it clear? Simple, right? Okay. So let us go for the next. Next is the displacement reaction. Next is what? Displacement reaction. Okay, fine. So what is the definition of displacement reaction? So these are the reaction in which a more reactive element displaces a less reactive element from its compound. Okay, clear? So this is the definition of displacement reaction. These are the reactions in which a more reactive element will displace a less reactive element from its compound. Okay, so let us see a example. So the reaction is between a copper sulfate and iron. Okay, the reaction is between what? The reaction is between the copper sulfate and iron. Okay, so what we have done here? So here, what we have taken? So copper sulfate and iron is taken. Okay, so what we do? We take 3 nails. Okay, we will take 3 nails. Okay, so we will take 3 nails. Now this 3 nails, okay, you have to clean it. Okay, you have to clean it with the sandpaper. Okay, with the sandpaper, you need to clean this 3 nails. What I will do, now I will take 2 test tube. Okay, I will take 2 test tube. In that 2 test tube, okay, so one is a test tube A, another is a test tube B. Okay, one is a test tube A, another is a test tube B. Now in both this, I will add, what I will add? 10 ml of copper sulfate solution. In both this test tube, what I have added? I have added copper sulfate solution. Okay, 10 ml. So this much I have added in both. Okay, 10 ml I have added in the both test tube. Now, what I will do? I will immerse 2 iron. Okay, 2 iron in copper sulfate. in test tube B. Okay, in the test tube B, what I'll do, both the iron, okay, these two, 1 and 2, I will put it in the your test tube B. So in the test tube B, I have immersed two nails, okay, two iron nails I have put. Okay, now what I'll do, one nail you keep as it is. Okay, okay, you keep this one nail aside, keep it as it is. This two I have added. Okay, this two I have added. This one nail I will keep it as it is. Okay, as it is, we will keep this nail. Fine. Now, next what you have to do. So keep this for 20 minutes. Okay, keep this for 20 minutes like this only. Okay. A test tube is like that only. Okay, A test tube consists of 10 ml of copper sulfate. Keep it like that. In B test tube also you have 10 ml of copper sulfate solution. But in that, what I have added these two nails. Okay, I have added these two nails. Okay. Then what will happen? So see after 20 minutes. Okay, after 20 minutes, what is formed? This where the iron, this was there, no iron, nails were kept, no. So that solution has turned brown color. Okay, it has turned brown color. Okay, the iron nails, they become, okay, what will happen? The iron nail, okay, it has become brown color. Just a second. So this is your test tube. Okay, in that test tube, what we have added? We have added the copper sulfate solution. Okay, copper sulfate solution, and we have kept this two nails. Okay, I have put this two nails. Now this two nails, what will happen to the two nails? Okay, after 20 minutes, what has happened to the nails? Iron nails, which it was dipped, no, it has become brown color. Okay, and whatever the blue color is there, that has become fade. Okay, this blue color has become fade. Okay, it has become light. Okay, this blue color has become light. So it has become light color. Okay, so this was the first test tube, okay, where we had taken copper sulfate, and this was a B test tube where we have taken copper sulfate and added iron. So after 20 minutes, the iron, okay, where it was dipped, it has become brown color, and the solution which was blue color, that has become faded. So what is the reason? What is the reason here? Yes, here you can see, here also you can see in the picture B. Okay, this is a picture B. You can see what? So first test tube, it consists of your copper sulfate solution, and this is the test tube which consists of B mixture. Okay, you can see that the iron has been displaced by copper. Okay, so displacement of iron is taking place by the copper. Okay, from the copper sulfate solution. So what is happening? The more reactive your copper has been displaced by the iron is displaced by the copper. So this is the displacement reaction is taking place between the copper and the iron sulfate. Okay, so you can see this also here. So here you can see clearly, right? So this is the clear test tube. So here this is a test tube A, which is consist of only copper sulfate solution, and this is the solution which consists of copper sulfate plus the nail. Okay, so this solution has taken what? It has become lighter. It has become faded, right? So what is happening? The displacement is taking place. Okay, displacement has taken place. So here you can see the reaction. So copper sulfate is there. Okay, iron is kept. So what is happening? The copper has been displaced. Okay, and this has turned light. So iron plus copper sulfate. So what is the reaction? What is the reaction? What we have taken? Iron is taken, which is solid in state. Okay, it has reacted with what? It has reacted with the copper sulfate solution, which was aqueous. Okay, and what happens? The copper, okay, has been displaced by the iron. So it becomes iron sulfate, which is aqueous, and copper, which is solid. So this is the displacement reaction taking place. Okay, so the element which is more reactive has displaced the lesser reactive element, okay, from its compound. Is it clear? So this is a displacement reaction. I hope it is clear, right? Very important, displacement reaction. So displacement reaction, what happens in displacement reactions? The more reactive element displaces a less reactive element from its compound. Okay, fine. Let us go for the next one. Next one is the double displacement reaction. Next one is the double displacement reaction. So these are the reaction in which there is an exchange of ions between the reactant. Okay, so what happens in double displacement reaction? There is a exchange of ions taking place. So already we have seen this example. Okay, so the reaction between the lead nitrate and potassium iodide to form a lead iodide. Okay, so it produces yellow color precipitate of lead iodide. So this is what? This is a double displacement reaction. So what happens? Your lead is there, it will combine with the iodide, and your this potassium will combine with the nitrate. So what you are going to get? Lead iodide and potassium nitrate, right? So what is happening? The exchange of ions is taking place. So this is the solution of lead nitrate, and this is a solution of your potassium iodide, and this is your lead iodide. Okay, so this is a double displacement reaction taking place. So lead is getting combined with the iodide, and your potassium is getting combined with the nitrate. So there is an exchange of ions between the reactants. Okay, so this is called as a double displacement reaction. Okay, this is called as what? Double displacement reaction. So let us see one more example. So this is another example. So what we have done in this example, we have taken, so what we have taken sodium, okay, we have taken sodium sulfate. So suppose I have taken 3 ml of sodium sulfate, okay, and in another test tube, I have taken 3 ml of barium chloride. So what I have done, I have added the sodium sulfate into barium chloride. So two test tubes. In two test tubes, there are two different solutions. One consists of sodium sulfate, Na2SO4, okay, Na2SO4, and this consists of barium chloride, that is BaCl2. So two solutions. In one test tube, I have sodium sulfate, another I have barium chloride. What I have done, I have mixed it. Okay, I have added this into this. So the resulted is this one. The product resulted is a white color. Okay, white color PPT is formed. Okay, white color PPT is formed. So what is this reaction? Okay, let us see what has reacted. Sodium sulfate, okay, which is aqueous in state. It reacts with the barium chloride, which is aqueous. It gives you what? It gives you, so your Ba will combine with what? Your Ba will combine with your SO4. Okay, so this is the white color PPT. So the white color PPT or the precipitate, it is because of the formation of barium sulfate. It is due to the formation of what? Barium sulfate. And this is solid in state. It is an insoluble solid, right? And plus NaCl. So NaCl will be left out. Okay, it will be in water-like format. It will be in water-like format. So this will be NaCl. This, okay, your white color precipitate. So this is your barium sulfate, and the rest will be your NaCl. Okay, so what is happening? So barium will combine with sulfate and your Na will combine with Cl. So what is happening? The exchange of ions is taking place. Okay, exchange of ions are taking place. So this is called as a double displacement reaction. So any reaction which produces the precipitation, okay, any reaction which produces the precipitation, it is called as precipitation reaction. What it is called as? Precipitation. Okay, it is called as precipitation reaction. What is precipitation? Precipitations are nothing but insoluble solid is formed like this. Okay, it can be a white color, it can be yellow color. Okay, insoluble solid will be settled at the bottom like this. Okay, so this is called as precipitation reaction. So any reaction in where a precipitate is formed, it is called as precipitation reaction. So the previous also, what was formed? Yellow color precipitate was formed here, right? So this is also an example of a precipitation reaction. So this precipitation is of what? It is of lead iodide. Okay, and here the white color PPT It was of what? It was of barium sulfate. Okay. So these were the example of your double displacement reaction. Next is the oxidation and reduction. Next is what? Oxidation and reduction. What is oxidation? Okay. What is oxidation? Oxidation is a gain of oxygen. Okay. It is a gain of oxygen or loss of hydrogen during a reaction. So whenever any reaction is occurring, okay, when you add oxygen, it is called as oxidation. Okay. When you add or when you remove, okay, when you remove hydrogen, it is called as oxidation. So addition of oxygen or removal of hydrogen, it is called as oxidation. Okay, and the substance, it is said to be oxidized. The substance which is undergoing oxidation, it is said to be oxidized. Then reduction is what? When you add hydrogen, okay, it is called as reduction. When you remove oxygen, okay, it is called as reduction. So you can explain oxidation with the help of oxygen also, hydrogen also. You can explain reduction with the help of oxygen also and hydrogen also. But remember that in oxidation, there is gain of oxygen, that is addition of oxygen, and reduction is loss of oxygen or removal of oxygen. Okay, so it is a vice versa. It is a vice versa definition. Okay. And the reaction, the substance, it is said to be reduced. Okay. Which is undergoing reduction. Okay. Let us see the example. Burning of magnesium ribbon in air. Okay. Air consists of oxygen. It gives you magnesium oxide. Hence the magnesium is oxidized. So what happens? Your magnesium. Okay. Your magnesium, what is happening? It will react with the oxygen. So what we are doing? We are adding oxygen. So when we are adding oxygen, what it is called as? It is called as oxidation, right? It is called as oxidation. So this is the reaction. Okay. This is the oxidation reaction. Why? Because we have added oxygen. So this is the oxidation reaction. So remember the examples, very important. Next example. So a few more examples of oxidation reaction. Okay. One more, a reaction. Okay. A reaction in which both oxidation and reduction takes place. Okay. A reaction in which both the oxidation and reduction takes place. It is called as redox reaction. It is called as what? Redox reaction. Oxidation and reduction takes place. So a reaction in which both oxidation and reduction is taking place is called as redox reaction. You can see, right? Redox, RED, okay, it refers to reduction and OX refers to oxidation. So it is a combined reaction. It is a combined reaction where you can see both the oxidation and reduction is taking place. Now, these are two examples of the redox reaction. So can you tell me which is undergoing oxidation and what is undergoing reduction? Anybody? Yes? Try to answer which is undergoing oxidation and which is undergoing reduction here. Yes? What is redox reaction? So redox reactions are the reactions where both oxidation and reductions are taking place. So here ZNO, yes, ZNO is reduced to Zn. So this is reduction. Very good. Kirti has answered. Very good. Okay. So ZNO has reduced to Zn. It is reduction. And carbon has oxidized, okay, to carbon monoxide. So this is oxidation. So there is an addition of oxygen here, and here there is a removal of oxygen. Very good. Okay. So ZNO, it is getting reduction is occurring, and from copper to carbon oxide, it is oxidation. Carbon monoxide, it is oxidation. Very good. Okay. Next example. Next example. MnO2 plus 4HCl giving you MnCl2 plus 2H2O plus Cl2. What is happening here? And what is happening here? Mg is MnO to MnCl2. It is undergoing reduction. Okay. And here you can see there is removal of so HCl is oxidized, right? It is HCl is oxidized to what? Cl2, and Mn2 is reduced to MnCl2. Okay, so this is oxidized. So this is oxidized and this is reduced, right? So your reduction is taking place. Okay, this is reduction from MnO2 to MnCl2. There is removal of oxygen, and here you can see there is removal of hydrogen. So that means it is oxidation taking place. So this is what? This is another example of redox reaction. So remember that what is reduction? Reduction is what? What is redox reaction? Redox reactions are the reactions where oxidation and reduction takes place simultaneously. Okay, fine. Yes, very good. Okay, let us go for the next one. So next important factor is effects of oxidation reaction in everyday life. Okay, in the everyday life, so what are the oxidation reaction taking place? So corrosion, okay, corrosion. So what happens? What is the meaning of corrosion? So it is a process by which a metal is attacked by substances such as moisture, acids, etc. Okay. So what is a corrosion? A corrosion. So a metal. So when it is exposed, when you keep it open, okay, when it is kept open to air, okay, or moisture. Moisture means nothing but water, okay, acid, different acid, etc. This metal will get attacked. Okay, it is called as that process is called as corrosion. Okay. So what is the examples? Okay, what are the examples? So what are the examples here? So what are the examples? So black coating on silver. So first one you can see black coating of silver. Then second one is green coating of copper. And this is a rusting. This is rusting of iron. Okay, rusting of iron. You can see silver. Okay, you can see this is silver spoon. Okay, how it has turned black. Okay, after it has been kept open to moisture, okay, or air, the silver, if you see, okay, it becomes what? It becomes black. After some time, what happens? It becomes black. Okay, so why it turns black? Because it gets attacked by different substances, so it becomes corroded. Okay, so this is the black coating on silver. So this is an example of a corrosion. Then copper vessels. Okay, in your house you might have seen copper vessels. So these copper vessels, if you don't clean them, if you keep it open like that only, it turns green color. Okay, it becomes green. There will be a green color layer formed on that copper vessel. So why it is also due to attack of the moisture maybe or oxygen. Okay, when it comes in contact with the air. Okay, if it is not clean, it becomes green. Okay, copper, it becomes green. Your silver, it turns black color. Then iron, you can see iron here. Okay, third and fourth picture, how it has turned. It has turned brownish, reddish brown. So iron things also, when you keep it open, okay, when you keep it open like that only, they turn corroded. Okay, they become reddish. This is called as rusting of iron. Okay, rust is formed on that. Why? Because when it comes in contact with the air or water, that is moisture, what happens? There will be rusting taking place. Okay, so this is the oxidation. So oxidation is nothing but when it comes in contact with air, oxygen. Okay, or air consists of oxygen. So different articles give different reaction. Silver, it forms black coating. Copper forms green coating. Your iron, it forms reddish brown color coating. Okay, that is called as rusting of iron. So these are some of the effects of oxidation in everyday life. Next is rancidity. Very important, rancidity. Okay, what is rancidity? When fats and oils are oxidized, they become rancid and their smell and taste change. Okay, so if pickles, okay, why pickles are stored in more oil? Okay, you might have seen why the pickles they are made in more oil. Then your potato chips, okay, when the packaging of potato chips, when you see the chips packet, it will be filled with the air. Why it is filled with air? So that it should not become spoil. It should its shelf life should be more. Okay, it should not become spoiled easily. So what they do, they put some air in that. What type of air it will be? It will be of nitrogen gas. Okay, nitrogen gas is pumped in that. Okay, so when fats and oils are oxidized, when these fats and oils which are present in the different substances, they get oxidized, when they become spoiled, okay, they become rancid. Okay, they become rancid and their taste and smell will change. Okay, okay, their taste and smell will change. So how you can prevent this? How you can prevent this? Okay, so for the foods which are containing fats and oil, you can add antioxidants. What you can add? You can add antioxidants. So how you can add antioxidants? Okay, what are these antioxidants? So which will prevent oxidation. So if you put antioxidants for the food containing fats and oils, okay, then your foods can be we can prevent them from becoming rancid. Okay, so this is the first prevention method. Second is you have to keep your food in the airtight container. Okay, you have to close it so that it should not come in contact with the air. Okay, this also you can do. You can keep it in the airtight containers. Then your chips packets, okay, they are, why they are so that it should not get spoiled. What they do, they flush them with the nitrogen gas. So these are okay, these are the prevention methods for preventing the oxidation and rancidity, okay, in your everyday life. Okay, so yes, so this completes our chapter. Okay. Yes, rancidity is nothing but your food gets spoiled. Okay, you cannot eat them. Why? Because of the smell and the taste. Okay, so because of that, so these are the preventive measures. Okay, fine. So this completes our chapter chemical reactions and equations. Okay, I hope you have understood all the things. So what all we have studied. So we have studied the chemical reactions, right? Examples of chemical reaction. Then we have seen how to write a chemical equation, right? Then how to balance a chemical equation. What are the different steps we have seen? Then types of chemical reactions. So 5 types of chemical reactions we have seen. Combination reaction, examples we have seen, different examples. Then decomposition reactions, examples we have seen, right? Then the third one, displacement reaction. So that also we have seen the examples. Then the fourth was double displacement reaction. Then we have studied about oxidation and reduction. Then we have also studied about exothermic reaction. Okay. Then we have studied about precipitation reaction. Okay, and exothermic reaction is what? There heat is released. What is endothermic reaction? There is one more called as endothermic reaction. What is endothermic reaction? In endothermic reaction, what happens? In endothermic reaction, heat is absorbed. Okay, when you touch the beaker, if any reaction occurs, if you touch the beaker, it becomes cold, very cold. Okay, heat will be absorbed. So this is the exothermic reaction, heat is released, and in endothermic reaction, heat is absorbed. Okay, remember this. Okay, I forgot to tell you about endothermic. Yes. So these are the things we have studied. Then what are oxidation reaction? What is reduction? Then we have discussed about what is redox reaction. Then we have discussed the effects of oxidation in everyday life, that is corrosion, rusting of iron, and rancidity. I hope you have understood. Yes. Okay, fine. So thank you. Thank you, students. Okay. Yes. So I'll end the session here. Okay. Thank you.